So I promised that I would tell you why it was useful to have these things measured in radians as opposed to degrees. One of the reasons is that if you have a circle with radius 1, it's called a unit circle. I will use this word many times, unit circle. Then we can, to each angle, now there's an angle, we call it theta, equals 0.64, right? This corresponds to 1 point on this unit circle. So how does this correspond? Well, we start measuring here, and then we go up to here. And how long is this arc? It's 0.64, right? Then I get a point on the unit circle. This point will, of course, have, any points in 2 dimensions has 2 coordinates, right? And the 2 coordinates here will be cosine theta, we call it, and sine theta. So cosine theta is the x-coordinate of this point here. And sine theta is the y-coordinate of this point here. In this particular case, where the angle is 0.64 something, in fact, the x-coordinate is 0.8 and the y-coordinate is 0.6. We can move this around, right? And then we get sines and cosines of all these degrees. Note that this angle here gets very close, and then it gets to 0, right? But the highest degree that you can see on this GeoGebra resource is something very close to 2 pi, right? So pi is 3 point something, this is 6 point something. So pi times 2. But in principle, I could have continued walking around this circle right here. So I could also make sense out of cosine of 10, right? Or -7 or whatever. But first, before we do something like that, let's just note a fact about sine and cosine. And this fact is hidden in this geometric figure here, right? What is this? This is a triangle, agree? And here we have a right angle, 90 degrees, or pi what? Pi half, right? This is an angle of pi half. So this triangle has 3 sides. We know the length of this side. Why do we do that? Well, it touches the origo and a point on the unit circle. So this length here has to be 1, agree? So what is 1 squared? 1 times 1 is 1. So I put a 1 here, because when you have a right triangle, you always have this relation that the length of this side squared times plus the length of this side squared equals the length of this side squared, right? That also applies in this case. And this gives us this formula here. The fundamental identity of trigonometry, it's called in English, or the idiot formula in Danish. So cosine squared plus sine squared equals 1. Note that I put the 2 here and here. That's just a matter of convention. It just means the whole number squared. So it's, in this case, 0.8 squared. What is that? That's 0.64, right? Plus 0.6 squared. What is that? That's 0.36, agree? So 36 plus 64, that adds up to 1. Oh, 100. So now we have the first 2 trigonometric functions. We have sine and cosine. You've also heard of the tangent function, right? How do we get that? Well, we get it like this. We put a line here that goes through the point. We get the line with the equation x equals 1. And then we see that this line can be extended up to this point here, right? And the height of this point is called the tangent, okay? So why is that important? It's important because tangent of the angle gives us the slope of this line. The slope is defined as how much should I go up if I take 1 unit step in this direction, right? So taking 1 unit step in this direction, I should go up in this case to 0.75, right? And the tangent can grow up to as big a number as you want, or as negative a number you want, and you can see that if my angle is more than pi half, then in order to cross this line, we have to go in the opposite direction, but then you just get this number still here. So that's how you get the tangent, okay? So this tangent, it can also be calculated using this formula here. Tangent of theta divided by 1, which is just tangent of theta, right, equals sine theta over cosine theta. So why is that? Well, note that we have a triangle here. I'll just put the angle over here because then it's easier to see. Then they are not on top of each other. We have a triangle here. We have another triangle here. What are the angles in these two triangles? Well, we have 90 degrees here. We have 90 degrees here. We have some angle here, and that is, of course, the same angle as this one here, right? If this gets small, the other one also gets small. They are sort of fixed to each other, right? Now, if you know two angles in a triangle, you also have the third one, right? So necessarily, this angle up here and the angle down here will also be the same, right? This means that this triangle and this triangle has exactly the same relations. So this line has length cosine, this line has length sine. So if we divide these two numbers by each other, sine divided by cosine, we get a relation, right? That same relation would hold over here, but the line that corresponds to this line over here is this line, and it always has length 1, right? So that's the one we have here. And then what is the length of this? Well, it's by definition tangent of theta, right? So if we divide tangent theta, the length of this line, by this line, we get the same number as if we divide this line by the length of this line by the length of this line. So having the tangent established, we can also define the secant. It's this length of this blue line here, and it's rarely used because you can find this number by just knowing. In fact, all the numbers, tangents of theta, secant of theta, cotangent and cosecant, can be calculated using only knowing only sine and cosine. But just to know the definition, you get this blue line here. The length of this we call the secant, and it can be calculated, as you see up here, as secant of theta divided by 1 is the same as 1 divided by cosine, by exactly the same argument as before, right? What is the length of this line? It's always 1. What is the length of this line? It's always the secant. So if we take the length of this and divide it by of the line down here, which is cosine, and divide by this, oh, we take this length and divide by this length, then we get the same as if we take this length and divide by this length. But this is always 1, right? So we get a 1 down here, and then the secant here. So the secant is just 1 over cosine. Okay, so let's hide those again. Now we get to the last two functions, trigonometric functions. There are 6 in total. The cosecant. And instead of putting a line over here, we put a line up here, and then we measure the cotangent as the x-coordinate of this point where this line crosses that. So given any angle, we get a line that crosses this line somewhere, except of course if this line is down here, right? But then the cosecant is not defined. It's an equal. A similar thing happens if this is pi half, right? Yeah, it's difficult to hit exactly, but you see my point, right? If this is exactly equal to pi half or 3 pi half, then the tangent is not defined. Oh, sorry. But the cotangent, anyway, is given geometrically like this, and you can calculate it as before. In this case, you should just say cosine divided by sine, which is the same as tangent to the minus first, right? And then you also have the cosecant, which is of course the length of the line from here to there. And again, there's a relation like this. So you can calculate the cosecant by saying 1 divided by sine of theta.